Good afternoon, everyone. My name is Dr. Philip Phillips, and I'm the Associate Dean of the University Honors College. Now, welcome everyone here to the Honors Lecture Series on the value of a liberal education. I'm very pleased to welcome our speaker today, who is one of our faculty members here in the Honors College, and in fact, one of our resident honors faculty members. Dr. Drew Sieg earned his undergraduate degree in biology at the University of Richmond and his PhD in marine chemical ecology at Georgia Tech, where he conducted research on chemically mediated interactions among marine plants, animals, and microbes. More specifically, he studied snail farmers. It's a really fascinating subject. He joined the faculty of the University Honors College in fall of 2013 as our first ever distinguished visiting honors scholar. In addition to teaching honors courses in biology, Dr. Sieg chairs honors thesis committees in various scientific disciplines, for which the dean and I are exceedingly grateful. He offers workshops for students on obtaining research grants and fellowships in the sciences. He directs various undergraduate research projects and constantly seeks new and innovative ways to make science more approachable and civically engaged. And I think that Dr. Sieg is a very engaging speaker. It's always fun to listen to his lectures, and I'm sure that all of you will appreciate his presentation today, which will be on the topic of the liberal arts and the sciences. Please join me in welcoming Dr. Sieg.
Thank you for that introduction, and I will freely admit that normally when I get up here I talk about a lot of scientific data, and so I'm a little out of my element today because we're going to be talking a little bit more about the humanities. But it seems like kind of a nice segue for me, because when I first enrolled at the University of Richmond, a small private liberal arts school, I was torn between majoring in history and majoring in biology. And so everything's sort of come full circle at this point with this lecture, I think. And so I'm going to start with a little bit of data. It's not the kind of data I normally present, but it's interesting nonetheless. So what we're seeing currently is a rise in STEM fields. And so by STEM, I'm going to say it frequently, I refer to it as science, technology, engineering, and math. So the hard sciences. And what we're seeing is that there's a rapid increase in the job market in terms of these STEM career fields. So in 2010, I believe, there was a presidential publication that came out called the Vision and Change Call for Educational Reform. And the big draw for this was trying to find ways to increase STEM graduates in the United States. Partially because within the next 2 to 3 years, we could be seeing 1 million more STEM jobs. And so with these STEM jobs, there's also a requirement to have at least a bachelor's degree before they move on. And so with that being said, I'm going to try and be a little more interactive with the audience today. How many of you would say that you're studying a major that falls under a STEM discipline? Show of hands.
Not according to you.
Not according to my definition, but we'll get to it. Okay, so a little over half of you. And so with this rise in trying to draw students into STEM, if you do a quick Google search, you'll find all sorts of interesting infographics like this that are visually really busy and not really the purpose of the PowerPoint, but these visually catching ideas as to why to major in STEM fields, right? Career opportunities are higher, wages are higher, et cetera, et cetera, et cetera. And these visually eye-catching things are sort of all over the place. But with this push for more and more science, technology, engineering, and math, there's also been a slightly unintended consequence at first, which is sort of this decline in the humanities and in the liberal arts. And so again, if you do a quick Google search and look for, science versus liberal arts or science and the liberal arts, you come across a lot of articles that look kind of like this. So the liberal arts are dead, long live STEM, liberals have killed the liberal arts, go get a math degree. As the internet fades as interest fades in the humanities, colleges worry. This article talks about how there's been, I think it was Stanford, one of the big California schools. Roughly 45% of the faculty at the university are classified as being within the humanities, but only 15% of the students. And so there's this strange balance between number of faculty and number of students. And also this other major exodus is from the traditional humanities courses. So in this article, they were talking about how At the University of Maryland, in just a 3 or 4 year span, they saw a 40% decline in English majors in the undergraduate level, largely due to the way that the university restructured their general education requirements. And so as they restructured it to try and alleviate the burden from English, the unintended consequence was nobody ended up wanting to take any English classes because they were never really exposed to them. And so we have these articles coming from different sides, and we also see it from the political realm, and there's a lot of interesting quotes you can pull up here, but this is my favorite. But this is Governor Patrick McCrory from North Carolina. It's not based on butts and seats, but how many of those butts can get jobs. And so the argument here is, in the increasingly technical society that we're living in today, in the Google generation, people are beginning to view college more as a technical school rather than a broad education kind of thing. And so if you major in 18th century Russian literature, will you ever be able to find a job? Is sort of the argument that's coming from some proponents of the STEM push. And of course, it is a factor that many STEM fields initially and through the course of the career will pay better than some of the careers within the social sciences, arts, and liberal arts as well. And so there is this drive, partially because there are higher starting wages in the health fields, business fields, and STEM fields, as opposed to the liberal arts. And that leads to all kinds of comics like this, and I love this one. So the perks of being an English major, right? So analyze this poem for me. I can't, I'm too busy. The president needs me to analyze this Shakespearean play, right? As a result of your exceptional prowess in English, we're going to give you all the money, all the jobs. And right, it's not really a fair attack on English majors. I find this one to be a little bit better. So is anybody familiar with the comics Piled Higher and Deeper? So it's a suite of internet comics that perfectly encapsulates what it's like to be a graduate student. And as a graduate student, I used to read these all the time and really relate with these different characters. They span the social sciences and biology and chemistry and everything else. But I noticed that there was this one guy over here from the comics that I'd never noticed before. And I was trying to figure out, well, what is his major? What is his deal? And I could only find like 3 comics on him. And it turns out that he was a humanities graduate student. And he got the axe pretty early on, right? So we got to inform you that due to the economic crisis, all humanities characters have been cut. Please leave the comic or switch to a more useful major. And so he'd been majoring in like 18th century Russian literature or something, and they decided to cut him. And so I'm not up here to start jabbing at humanities versus liberal arts. I'm just trying to set the stage of the climate that we're dealing with currently in academia sometimes. And sure enough, we do see, if you look at who's graduating in the university setting these days, we do see a higher proportion in business and STEM. And it's easy to say, well, with these most recent advances in technology, that's why we're seeing this major shift. But to be fair, this initial drop-off in some of the humanities fields actually occurred in the early 70s, progressing through until about 1984. And it had less to do with advancing technology so much as the changing gender demographics in the college setting. So as more women were attending colleges, there was also a shift in what fields they were majoring in. And that shift sort of declined from the humanities and increased in STEM and technical fields. So that's one component. And so what I'm getting at is this isn't a brand new recent advance. Right? But we do see this shift towards the STEM fields. But the question then becomes, is it working? And so the president has said we need more STEM majors. Businesses are saying, in some cases, we need these technically trained individuals. But if you look at what actually is going on, so this is sort of a crazy busy figure at first, but what it's showing are different major areas of study at the undergraduate level on the left. And then on the right, it's saying how many of the individuals from those different fields went into STEM or non-STEM disciplines. And so what we find is that in the computer sciences and engineering, so the sort of T and E of STEM, we have about a 50% movement of people that majored in that field and actually continued in that STEM field. But if you get into in chemistry and biology and some of the social sciences, we see it's only about 10% or so actually continue on into the STEM careers. And so even though we have this demand for jobs, not everybody that's going into major for one of those jobs actually ends up doing it, right? And what's really interesting is if you start to read a little bit more into the STEM versus liberal arts debate, and it's always kind of fun on the internet to dig around in the comments section, you find some really interesting things. And so here, this was based off of an article, one of the articles I showed you previously talking about this shift. Those that gravitate towards STEM are becoming narrow thinkers and lose the ability to look at the big picture and think critically, which I find strange because one of the major points of science education in today's climate is critical thinking. This one was a little harsher. I wonder if our emphasis on STEM is not turning out a less than human kind of human, one that without literature and art has become incapable of understanding any values that can't be expressed in numbers, which kind of hurts me as a scientist. And then there was another one that I didn't put up here because I didn't want it to look too texty, but they said, a university without a philosophy department is no longer a university. I was like, okay. So there's this perception in some circles that by progressing more towards the STEM fields, we're sort of losing our humanity, and we're losing our ability to view the why and the beauty of things. And so we're going to try and remedy that situation through the rest of this talk. And if you're interested in this argument a little further, if you want to see the polarized extremes of this debate, I'd point you to two, actually three New Republic articles that have been published within the past 2 years. And it started as an editorial, Science is Not Your Enemy by Steven Pinker. And Steven Pinker is an editor for the journal with a science background. I think he's in psychology. And he argues that as we get into a more technically literate society, the humanities need to find new ways to incorporate advances in science into their coursework. And that's not to say that science needs to overcome the humanities, but rather that there are ways that both science and the humanities can work together. And also to point out that scientists can see beauty in things. Just look at the expansion of the universe or microbial life, things like that. There is a certain beauty in those fields. And so he provides lots of examples, such as in political science, being able to hook up monitors to track brainwaves during political elections, or determine the electability of somebody based on their facial expressions in a static photo. These are scientific areas that then can contribute into the humanities and into philosophy as well. As a scientist, I felt pretty good about this article, showing sort of synergy, right? But then one of the main editors of the journal came back with this rebuttal: crimes against humanities, now science wants to invade the liberal arts, don't let it happen. And in this article, it sort of said, leave the philosophy to the philosophers. Science already has a pretty large piece of the pie, don't let them invade this sector as well. And that's great that in some cases we can benefit from science collaboration, but you need to keep philosophy to philosophy. And so to sort of summarize the views then, this is the Pinkertonian view, and this is the Leisler view a little bit more. And with this sort of dissenting opinion, he said, it's not for science to say whether science belongs in morality and politics and art. These are philosophical matters. Science is not philosophy, even if philosophy has, since its beginnings, been receptive to science. So it's sort of like, do you want to work together? Do you want to sort of maintain these individual silos? And again, these are extremist views in this case. This is not what's going on across the university landscape, but these ideas do persist. And one of the arguments that is made in the dissenting article proposes that if we take a purely scientist view of art and of the humanities, it will take all of the sort of beauty out of those fields. And so he points to a picture of Chardin's cherries, and he says, so it's a still life, we've got cherries over here. And again, try and work with the audience a bit. How would you describe this picture? Like, take maybe 30 seconds and talk with a partner and say, what do you see in this picture? And you can take it from a humanities standpoint, but maybe you can also think about, well, how does science tie into this picture at all? And take like maybe 30 seconds and just chat with a partner. What do you see in this picture? Beyond walnuts and plums. It's kind of a dark picture. I hear that feeling as well. All right, so let me reprise. So let me see one of my science people. Raise your hands if you're in the STEM fields. Okay, somebody feeling bold. What do you see? Fruit. So you got fruit. Anybody else want to contribute further?
Can you clarify for me, because you said hard sciences in the introduction, and then your pictures did include the social sciences.
Sure.
So are you including me or not?
I'm including social sciences. You can become in the STEM embrace if you want. Sure. Okay, so what else we have? So we have fruit. Anybody want to contribute further?
Order and chaos.
Okay.
Yeah, I would agree with order and chaos because that's.
So we got some order and chaos going on. Were you a sciencey person or were you a humanities-y person?
Science.
Sciencey, okay. So you were able to see beyond just the physical fruit, right? But the argument that the New Republic article makes is that if we take a purely scientific view and we leave the humanities to the scientists, all we would do was try to chemically analyze the different pigments in all of the different fruits, and then determine how their mixtures together produce the pigment color that we're seeing, and that's all we would see in the image. And I think we've just demonstrated that even us scientists can see beauty in this art to varying degrees, be it there's cherries, which is still an observation, or chaos and beauty and things like that.
There are a lot of spheres in that too, so even
Sure.
from a scientific perspective, you've got a geometrical theme going on.
Absolutely. There's a lot that you can work with on this image. And this is an argument that's actually been made for decades. And so if you, I'm trying to think if it was, is that Weinman? One of the leading scientists involved in the Manhattan Project was asked a similar question by an artist. And the artist said, you might be a really brilliant scientist, but you can't see the beauty in a flower. And then his response to that was, well, I can appreciate the aesthetic beauty of it, but through my scientific knowledge, I can also ask questions such as, why does the flower have the shape, the morphology, the odorants, the colors that it does? How does it attract insects? How has the pollination scheme evolved between the insect and the plant? And there's a lot of beauty in these sorts of fields as well. And so while we might not be able to describe necessarily all of the artistic qualities, there's still beauty in something as simple as a flower, right? Okay. And if we look back in history, you can see that many of the great philosophers and great thinkers of the past had an integration of both the humanities and the liberal arts and the sciences. So Plato and Aristotle, while they did contribute tremendously to the fields of philosophy, they also looked into aspects of science. So understanding deductive reasoning and skepticism and being able to have a demonstrative science, all of these ideas that Plato and Aristotle laid out helped found the foundations of how we actually conduct science through hypothesis-driven research. And they also delved into chemistry and physics and other fields as well. And while their current or the models that they proposed in terms of how atoms work weren't there, they were still thinking about the ideas of matter and compounds and how compounds can come together or break apart. And so, for instance, Plato proposed that the different elements all had different size-shaped particles, right? And so Earth was a cube and air was an octahedron. But if you put these ideas together, he would say that, well, water is really just a combination of 2 air and a fire, because you can add up the sides and make it 20, or 8 plus 8 plus 4, 20. And so he had these ideas that there was matter, and matter could break into different parts and pieces. And Aristotle built on this idea, saying that, well, if you combust wood, then you get particles of air, you get particles of fire, and so on and so forth. And then later thinkers, of course, couldn't really contribute as far as they did without embracing the liberal arts and humanities as well. So a lot of the advances that Da Vinci made couldn't partially have been done if he didn't have a strong foundation in the arts, right? And being able to sketch and draw anatomical figures and so on and so forth. And so we've seen in the past this integration of liberal arts and sciences. And so it's weird that they're now trying to sort of separate the two. And so I decided to be kind of pragmatic with this. And many of you are hopefully planning on going on and getting a career after you leave college, right? And so I did a little bit of digging with the American Association of Colleges and Universities, and they did a broad survey of over 300 different employers to say, well, what are employers currently looking for in their workforce? And the first thing, the most important thing, was they want innovative college graduates, which is kind of a broad statement, but it makes sense, right? They want people that are innovative. They don't want non-innovators in their field. But if you delve into this a little bit further, you find a few more specifics. So 82% want critical thinkers that can undergo analytical reasoning and problem solving. 80% want strong written and oral communicators. You need to be able to write, you need to be able to listen, you need to be able to talk. And you also need to be able to apply your knowledge to real-world settings. And so regardless of if you're in the liberal arts or the sciences, these are 3 critical things that your college career should be able to get you, right? Nobody wants to hire somebody to solve a problem that's already been solved before, sit in a box by themselves and never expand on anything that they found. They want you to be able to elaborate. They want you to be able to communicate. And the other interesting thing about this is that 93% felt that these three qualities were far more important than the actual selected major at the undergraduate level. Right? And so regardless of where you find yourself between the humanities and the liberal arts and the sciences, if you can be a critical thinker, if you can communicate, and if you can apply this knowledge to real world settings, you're going to be marketable on the job market. Now, those of you that raise your, well, it might not just be your STEM people. How many of you are considering graduate school or medical school? All right. Almost everybody in the room. How many of you are thinking about medical school? A couple. All right, I'm going to pick on you guys. The pre-medders are always fun. So what do you have to do? Like, what is your next big step in terms of getting into medical school? The MCAT. What is the MCAT? What do you have to do for the MCAT? Study, 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 study. Never have any friends, just study and never do anything ever again that's ever fun because I have to get into medical school. I've been to many different institutions. Pre-med people are always the same. I used to be one too. And so my other point here is that I'm not sure for those of you that are planning on taking the MCAT, but in 2015, the board that actually releases the MCAT changed the structure of the MCAT test. And so it used to be a 3-hour, 20-minute test that looked into physics, biology, and sort of critical thinking problem solving. As of 2015, they have upped it from 3 hours to 6 hours and 15 minutes. So they've doubled it. And why they've doubled it is they've added additional components that they think a modern doctor needs to be able to do. So things like psychology, communication, and also like being able to interpret data statistically. So skills that are going to further build beyond just can you memorize all of the bones in the body, and then can you communicate your findings with your patients? Can you understand where a patient is coming from, and can you interpret data? Right? So for those of you that are getting ready to take the MCATs, I apologize on behalf of science that you have to do double. But the other thing is that almost everybody in the room raised their hand in terms of wanting to go into graduate school. And so by being enrolled in the honors college and progressing through your classes, you've been doing pretty well. You've been able to maintain a high GPA and so on and so forth. Once you get into graduate school, you'll realize everybody else has been equally impressive in all of their academic credentials so far. High GPA, lots of service, everything else. And what's going to distinguish you at the graduate school level is, can you think outside the box? Can you creatively solve problems? Can you work together? Those same exact ideas that were in my little triangle image a minute ago. If you just know everything in your little subset field, but you don't know how to communicate any of that with anybody else, you're not going to be as strong of a graduate student. So keeping in mind trying to find ways to sort of be able to increase your critical thinking, increase your communication is important. And so we can play another little game here. And so we need to be able to do analytical reasoning. So we have here a graph that shows the correlation between Japanese passenger cars sold in the United States and suicides by crashing a motor vehicle. We have a strong positive correlation with an R value of 0.93. And now take another 30 seconds and talk to your partner. Does this correlation make sense, yes or no, and why? How much weight can you give to this particular correlation? Okay. So what do you think? What do we got? Doesn't make sense. So basically, yes, we happen to see trends between these two things that follow on a yearly basis, but there's no reason to actually think that the number of Japanese cars is leading people to want to kill themselves while driving said cars, right? And we can take this same idea a step further. I love this one. Letters in winning word of Scripps National Spelling Bee versus number of people killed by venomous spiders. We still have a strong positive correlation, but you've correctly been able to identify that doesn't really work. You've been able to critically analyze this data set and say, well, hang on a second. Just because the lines are following a similar path doesn't necessarily mean that there's anything to this correlation. And preface to the next slide, I am not in no means trying to get into a political argument here, but we do see these kinds of misinterpretations of data throughout the political realm as well. And one that struck my interest over the past summer is when they were trying to defund Planned Parenthood. And they showed a figure that looked like this during the Senate hearings. And so we see increases in abortions, and we see decreases in cancer screenings. And so the proponents that were trying to defund Planned Parenthood in this example were saying, you're spending more money and more time and effort on abortions rather than cancer screenings. That's not cool. You can't do that. And the director of Planned Parenthood that they were interviewing at the time said, I've never seen this data before. This doesn't really work. But it's a graphic visual image. You see this negative correlation between the two. But what you can tell when you notice a little bit further is there is no y-axis on this figure, right? And if you actually look, they've sneakily added the actual values for the start and end points here. And so if you add a y-axis in terms of raw numbers, the graph goes from that to this. Abortions, pretty much level. Cancer screenings are on the decline, but do you see a correlation between the two? Maybe not. And then also, they've picked one of the non-abortion services that Planned Parenthood does that has one of the steepest declines. If you sum up all of the non-abortion things that are done at Planned Parenthood, the graph ends up looking like this, right? And so again, I'm not arguing pro-life or any of that, but I am saying that to be a successful member in society, you need to be able to critically analyze data and understand the interpretations, right, of this data set. Okay, so another little quick thing. So if I were to say, who's a famous scientist that's currently alive, what ideas come to mind? Who jumps out? Stephen Hawking. Anybody else? Neil deGrasse Tyson. I'm playing a game with you. Who else? Not a scientist. Not a real scientist. Any other actual scientists come to mind? Maybe Bill Nye? Okay, so I got 3 of the 4. Right, so we got Neil deGrasse Tyson, right? Michio Kaku, I figured would be a long shot. Stephen Hawking, and Bill Nye, right? And so when I was thinking about what makes a popular scientist today, it's that they're all effective communicators, and they all sort of delve outside of their disciplines and are able to communicate science effectively with a broader audience. And to do that, they had to have a broad training, both in the liberal arts and the sciences, and be willing to embrace sort of this the nature of written and oral communication to be able to express themselves beyond just the sort of pedantic science-y words and jargon that scare everybody away from the sciences. And what's interesting is if you look into the backgrounds of several of these pretty famous scientists, you find interesting correlations. So you might know that Neil deGrasse Tyson was also an accomplished dancer. So you got your arts embracing there. He was a wrestler. He was on the crew team. Bill Nye was a stand-up comedian before he went into his Bill Nye the Science Guy career. Stephen Hawking also has a strong interest in both classical music, science fiction writing, and before his paralysis set in, he was also a member of the crew team. And so they had this sort of embracing of both the humanities and the sciences early on in their education. Okay. And so what I'm going to do now is give you a couple of vignettes of ways in which we can try and bridge this gap between and try and break down these barriers between the social sciences, the humanities, and other STEM fields. And to start off, I'm going to look at Stanford. And so Stanford has embraced this idea of digital humanities. So finding ways to incorporate modern technology into the interpretation of classics and history. And 2 examples that jumped out with this is there's a course called Teaching Classics in the Digital Age. And they use a program called Rap Genius. Anybody ever heard of Rap Genius before? Because I hadn't. Okay, we got a couple of them. So what Rap Genius does is it's an open source Wikipedia type program where you can write out the lyrics of a particular song and then annotate it. And so with most rap, so there'll be references to other artists and other rappers or other historical events or whatever is in the song, you can annotate it. And as you read through the lyrics, you can highlight an area and it'll say, well, this is what the artist is referring to. And so within this particular course, they use this to teach the Iliad and the Odyssey and other classical works where they add in blocks of text from the Iliad or the Odyssey, and then the students have to annotate it just like they use with Rap Genius. So it's an embracing of this modern technology to still get a classics field across, which I thought was cool. I couldn't find a specific example of that, so I just pulled up a State of the Union address. So political scientists are using this too. And then another one that's pretty neat is called Orbis. And this was a graduate student project that then developed into a compendium of the course, where this student was a history major, and he was using programming software, mapping software, and socioeconomic data from the Roman era to basically build a MapQuest or a Google Maps of ancient Rome. And so he wanted to try and determine, in realistic terms, how long would it take to travel from, say, Florence to Athens or anywhere else. And so he put in the major hubs of the Roman Empire, and then also determine your based on how much money you had, what sources of travel you had available, horses, boats, et cetera, how long would it take for you to go from point A to point B, how much would it cost you, what was your likelihood of success. So again, it's taking history, but then bringing it a modern spin and a modern twist to it. So I thought those were kind of interesting examples. And if you look at the undergraduate level a little bit more, there is a push where not only do we need more STEM majors, but we need STEM majors that have some liberal arts training as well. Students that can think outside the box to sort of check off those points of the triangle we saw earlier. And so there's a big pedagogical push to try and develop merged courses between a traditionally humanities field and a science field. And so I'm going to show you a couple examples of that. The first is taught at RIT up in Massachusetts, and it's a civil engineering coupled with history course. And so what they do is the objective of this particular engineering course is to figure out how to limit pollution to the Blackstone River. But the part of the story that's interesting is they do it from a historical perspective. And so the students have to only assume that they had the technology available during the Industrial Revolution, because that's when pollution actually really kicked in this particular river. And so they have to go back in the historical record, figure out what the conditions were like, figure out what technology was available, and so on and so forth, to propose a cleanup strategy using the technology of the time. So it's this sort of merging of history and engineering. And then one image does not do this one justice. But at Duke, there's a program that has blossomed to an extent that you can't really express in words. So there's a professor there named Cheryl Braverman, who I had the opportunity to meet over the summer. And she was teaching an interdisciplinary course for non-majors to try and introduce the idea of the AIDS epidemic. So teach the biology of AIDS. And she wanted to bring in a humanities component to this. And so what she did initially was she set up a collaboration between her students and an internet cafe in Kenya, where the students could contact Kenyans and ask them about their personal experiences with AIDS, how AIDS is transmitted, what do they know about it, what do they want to know more about, and so on and so forth. This was sort of the initial bridging of the humanities and the liberal arts and the sciences. Since that point, as they were getting feedback from the locals in Kenya, they basically translated this idea to sort of say that within Kenya, there is a major increase in the AIDS epidemic, and it's partially due to cultures near water sources where women, after reaching puberty, can't afford sanitary products. And so in order to afford sanitary products and continue to go to school, they have to prostitute themselves. And as they prostitute themselves, they see an increase in the AIDS within that particular demographic and or pregnancy, which then limits the women's exposure to secondary education. And so this caught this professor's interest, and through collaborations with engineers, they found ways to bring in clean water. Through collaborations with businesses and outreach, they found ways to get sanitary products to this area. To increase women's education in the high school setting, they actually built a school in Kenya. And all of this stemmed from this one initial collaboration. And so, I mean, like I said, one slide doesn't do justice to just how much this sort of has blossomed, but it just sort of shows how far-reaching these ideas can go. And then one other area that I kind of want to highlight is this idea of going from STEM and then incorporating the arts to make STEAM, which I know acronyms are always fun, so STEM to STEAM. And this has taken off pretty well in the K-12 realm, and it's starting to take off in the college level too. So at the K-12 realm, for instance, there's a teacher in Baltimore City Schools that teaches how to calculate acute and obtuse angles by using Kandinsky's arts. So students get images, and then they're told to use a protractor and calculate the angles that are drawn here. And so it's a relatively easy way to integrate both math and art together. And then at the community college level, In the Northern Virginia Community College, they've created a STEM curriculum where they couple biology and visual arts. And so students have to take a concept that they learned in their biology class and then use a visual media to try and actually integrate what they've learned. And so in this case, this particular student built a series of ceramic vases to represent the different stages of a zebrafish embryo. And you can't really see it from the picture, but the student was incorporating elements inside the bowls too to represent the development of the embryo at different stages. So just as a simple example there. And even here within Murfreesboro, at the Discovery Center, we have a STEAM bus. And the STEAM bus is the same STEAM that we're talking about here. And so the STEAM bus will travel from school to school and find ways to do science experiments with high school and middle school and elementary school students that incorporate both the arts and the sciences together. So like I said, there's a big push in the K-12 area. We're still delving into it a little bit more at the college level. But one example of it that I did want to highlight is going on at UC Davis. And UC Davis has actually developed an entire program around this concept called Art-Science Fusion. And so with this course, you pull in students from a variety of majors, and they get both science and arts training simultaneously. And they can do this through different kinds of courses. But the one that caught my eye was Art Science in the World of Insects. And so this is technically listed as an Entomology 101 course, but it incorporates both entomology and visual arts. And so what they have to do is each student, so there are 22 students on the year that I looked up, from 12 different majors. And each student at the beginning of the semester was assigned a different species of bee. And they had to research the natural history of that bee, the pollination strategies of that bee, et cetera, and learn everything there was to know about their particular species. And then use that information to help build a collective mural, each tile or each hexagon representing one of these species of bee. And so with each of these, we're seeing different species, and they're trying to highlight the different ways in which these individuals pollinate a field. And then they've had other art projects since then, such as decorating bee boxes and things like that. But there's a lot of creativity in here. And so they're still getting the entomology information. They're still getting the content, but they're applying it in a way that's very novel and unique, right? And so if you look at some of the surveys after these classes are run, you find out some pretty interesting stuff. So I learned quickly, I cared more because I was involved in it. It makes you learn content so much deeper and with more meaning. Being collaborative in the arts trains you to be collaborative in the sciences. So all of these aspects that these employers are looking for. The information I've learned in this class will be retained so much better, and why can't all of our classes be like this, right? So finding novel ways, especially at those first 2 years, to draw from people's inspiration, draw from people's creativity to create a course that both gets the STEM content across, but also develops the individual as a whole. And so all of these things, they're developing interdisciplinary communication, they're fostering critical thinking, they're finding new ways to keep student interest, and they're fun and different, right? And so now I've just highlighted a bunch of fancy schools out in California. So where do we come in, right? So there's our honors college. Yeah, you're sitting in it right now. And so just as a couple of examples, take advantage of those interdisciplinary seminar courses, your junior interdisciplinary seminar course, for instance. So I had the opportunity to sort of embrace that history and science side of me last year when I taught a course called Magic, Myth, and Science. And so what we did is we looked at sort of the changing weight of science, mythology, and religion, starting with the ancient Egyptians and moving all the way up to the current era. It allows you to make really interesting comparisons. So we talked about the Salem witch trials. Not quite the right one. And we talked about some of the chemical, biological, and psychological reasonings why the Salem witch trials could have initiated in the first place. And my students were like, yeah, but that was the 1600s. That's never going to happen today. And I said, well, what about the Red Scare? And like, well, yeah, there was a lot of fear-mongering going on then, but it was still a little bit while ago. And I said, and this timed out perfectly because then I said, well, what do you know about Ebola, right? And they're like, wait a minute, I don't know much about it, but I am really scared of it. And I don't know if I want anybody else to come into the country, so we got to figure this one out. And so then we were able to talk about the biology of Ebola, work out the misconceptions while still relating it to previous fears that we've had in the past. And so these are the kinds of courses that the Honors College can provide to you to really draw in these interdisciplinary avenues of research, right? And then also, how many of you are dreading your thesis? How many of you know what your thesis is going to be? Not half of you. Okay, you can get really creative with this. So at the undergraduate level, you should take advantage of this ability to expand your fields of interest and your fields of study. So when I was an undergraduate, I got to take acting classes. I got to take art classes. I didn't have time to do those things in graduate school, but as an undergraduate, it helped shape what I wanted to do. And your honors thesis can be an extension of that kind of philosophy. So we had, I just pulled up 3 random examples. So Thomas Nyes in 2014, he looked at the mathematics behind magic tricks. And so card tricks and other visual tricks looked at ways to sort of show how simple mathematical principles are at play in card tricks. And then he tells you how to do them too, which is fun. If you want to read it, it's up there. A more recent one, Brenton Andrews, looked at aeronautics and history and sort of looked into how different was Da Vinci and, well, I can't think of the other guy's name. No, it was a monk. No, it's a monk. It starts, an English monk whose name is failing me at the moment. But anyway, they both tried to create flying machines. And he looked into the constraints on their models and why they might not work from a modern aeronautical standpoint. And then he actually built scale models of these and tested them out himself. So again, history and engineering coming together. And the one that's coming up to be done soon, she's not in the room, is she? The Morgan Davis, a previous student of mine, is she's minoring in dance. And so she's looking at how to teach Common Core math concepts through dance, right? And so not necessarily those guys there, but she's looked at what the Common Core wanted and then developed a series of dances for a concert, all relating to the mathematical principles she wants to teach. So again, liberal arts and sciences being happy together, right? And then also a benefit of the Honors College is being able to undergo independent research or collaborative research. And so looking for ways to partner with faculty, both through your thesis and through other projects. These were 3 of my students 2 summers ago that investigated colony collapse disorder. And so they had never really planned on studying bees, nor had I, to be perfectly honest with you. But we were able to develop this ecological project and come together through the Honors College. And then take advantage of the integrative travel abroad and study abroad experiences that we have, where you can bring in history, you can bring in English, you can bring in these different fields. And then finally, because he's here and I wanted to embarrass him, you can also deal with our eclectic faculty if you want to meet a former president for the day, right? So the environment that we create here in the Honors College is very conducive to these kinds of ideas that I'm presenting, right? And so take advantage of them. And I'll leave you with that. Actually, I'll leave you, yeah, that's a good spot to leave you. I have a different slide, but I'll just leave them up there just to keep you uncomfortable. So that I'll take questions.
Dr. Sieg, we do have some time for questions or comments, so please, any questions or comments for our speaker?
So you're saying that one of the main benefits between the hybrid classes of the liberal arts with the sciences is that it provides a new way of learning and absorbing and looking at the sciences rather than the value of the, let's say, like take the PE mural, rather than the value of the mural itself, more like the fact that the students absorb the information.
Right, so it's this idea of sort of having personal investment in the project to begin with. And a lot of times when you go to sort of pedagogy conferences, when you propose new ways of teaching beyond just the cookie cutter labs and sage on the stage lecturing, the first question that older faculty will come to is, but we won't get through all the content, or we won't be able to get to all the material. And what you find is actually that because the students are typically, and it's not for everybody, but typically are going to be more engaged, they actually take a lot more away from it. It's not just test, 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 and now I can move on to the next class. They'll remember that bee project. They'll remember the specifics of their species that they had to study and the ecological concepts therein. And so that's one of the benefits. And I think that arguably it's especially useful for the introductory level courses where you're trying to initially hook somebody in their field and in their major. And so like I teach an introductory biology class where we scrap all the cookie cutter labs, and instead we spend the entire semester trying to isolate antibiotic producing bacteria from the soil. And so what it's doing is it's exposing students to authentic research early on, right? And there's this drive to potentially find the next new mega drug, right? And it can lead into honors theses and other projects like that. But they remember the material because we relate molecular genetics to when we're doing PCR. We connect evolution to antibiotic resistance and so on and so forth. And so the material stays with them a little bit more because of this sort of synthesis. Yeah.
Do you anticipate teaching the Magic Method Science course again?
I would like to. We'll have to see.
You as well. I wanted to take it, but I had to take that analysis to be able to take my summer seminar.
Well, in the event that I don't, come and see me, because I can give you the syllabus and the course links and all the material that I did, because there's some really fun topics in there. Including Bigfoot, which
Yes.
Dr. Phillips asked me week by week by week, when are we doing the Bigfoot lecture? And when we finally did, he came and sat in on it.
Right.
What you talked about there in sociology we call moral panics.
Absolutely.
When you do that.
And what was beautiful about teaching that course is that we had a hodgepodge of every major possible. And so I'm not a sociologist, I'm not a behaviorist, you know, I don't study humans, I study snails. But being able to draw, like we had a student that was interested in neuroscience, and so she talked about like release of particular different hormones and how that can affect brain chemistry and stuff like that. And we could tie all these different ideas together, which is really cool. Any other questions? Yeah.
You said that early on that there was the connection between liberal arts and sciences. What do you see as pulling them apart and making them as different? And what's the main impetus behind it?
Well, I think that a couple of the pulling apart factors, one is funding. So generally speaking, the STEM fields are going to have a higher proportion of the funds coming towards their particular disciplines, which then will attract more students, and then it sort of becomes a cascading effect. And depending on whether you ask scientists or professors in the humanities or everything else, like the divvying and the division of funds there can be argued as to what is appropriate and what is not. But I think that that's an initial pull, and then this idea that of sort of viewing college more as a technical school as opposed to as an all-encompassing becoming a citizen of the world idea that is sort of taken off is naturally drawing students that only want to study for the MCAT. They're only going to take courses that directly apply to their specific discipline, which arguably will make them less competitive in the long run when they get up to that next level and they've become so hyper-focused that they can't see the forest for the trees sort of thing. And so for those of you that are planning on taking the MCAT, do take some humanities courses. It will really make you stand out and be able to express yourself in these fields. Trust me, it helps.
Take those philosophy courses.
Absolutely. Any other questions? All right, great.
Thank you.
Mm-hmm.